RFmaker. Build radios and listen to the world.
Hi everyone, welcome back to the RFmaker channel. In this video, we'll measure the frequency response of the IF amplifier and see how it performs in practice. Let's get started. Before we start, let's take a quick look at what happened in the previous part. I showed the adjustable features of the IF amplifier and we tested how it behaves in a real operation. If you missed that video, just type RFmaker IF amplifier into YouTube, find the first part and check it out. Here you can see the finished PCB of the IF amplifier. I've been using this design successfully in several of my projects. Now let's power it up and start the measurements. Before we move on the frequency domain, let's take a look at the basic operation in this current setup. With a 455 kHz input signal at the 50 mV amplitude, the output is already above 200 mV. So in this configuration the amplifier provides roughly a 4 times gain, with plenty of headroom left. Now let's take a look at the frequency response using the FFT analysis and the built-in tracking generator. I speed up the video a bit here. For this type of measurement, it's a good idea to disable the trigger on the oscilloscope. During this part, I'm setting up the FFT tool and switching the generator into sweep mode. We are using the FFT with a 1 MHz span, along with a few important settings required for this analysis. We run the sweep generator from 350 kHz up to 550 kHz. After a few seconds, the frequency response starts to appear clearly on the screen. Let's perform a bandwidth measurement using the frequency response. Let's locate the peak frequency. I set the y-axis cursor to this point, and I set the other y-axis cursor 3 decibels lower. Now, using the two adjustable x-axis cursors, we can determine the lower and the upper cutoff frequencies. As you can see, the bandwidth is roughly 4 kHz, and there is a slight asymmetry in this filter. We can measure the frequency response even without an FFT or a spectrum analyzer. If you have a simple oscilloscope, you can still determine the frequency response. The idea is simple, you measure the amplitude at the different frequencies. Let's create a table with the frequency and amplitude values, either in Excel or on paper, and define the measurement steps. Here's a tip: the closer you get to the expected peak frequency, the smaller the frequency step should be. We will check the first two measurement steps, and after that I speed up the video so the final result appears quickly. With a basic oscilloscope, you can do this using the scale divisions, while in my case the scope directly displays the amplitude. So, this is the result table. Now let's create a chart and choose one of the recommended chart types. This chart type shows the general shape, but if we switch to a bar style view, the asymmetry becomes much easier to see. Try this method out, it works well. If you enjoyed the video, please subscribe.